at 11:05, which is the actual time. Got it? So how is everyone? We are live now, as you can see on your screens. Yes, we are live, students. Every one of you is live now. You can now watch it from YouTube also. It's working there properly. Okay, it's on the YouTube also. Got it? Yes. So now let us start the slideshow. By the way, so welcome to today's class again. कैसे हैं सब? How's everyone? How are you, students? How's going on? Okay. So see, PPT slides visible hai, to baat khatam. It's enough. Be focused on the PPT slide. Today I'll be not doing a lot of useless talk. Okay. So just this topic oriented talk will be there in the class. Okay. So today you have Sunday. It's like enjoying day for you. So I will not waste you a lot of time. 50-60 minutes of the class. Okay. Then we'll end it. Got it? And how many students have joined here on the Zoom plus YouTube? Okay. So there are many students here from JNV DU. You are also from JNV Ratnagiri, JNV Sangli, Satinder Singhmar is also there. Okay, welcome. Welcome everyone, okay? So I'm audible properly, yes or no? Yes or no, students? Audibility to hai na? I'm audible, yes or no? That's not? Okay, that's nice, cool. Okay? So let us start it. I'm starting the class. I must be audible and I hope I'm audible for all of you. Let me check on the YouTube also for once again. Last, this is the last final checkup. Is my voice audible on the YouTube? Okay, let us start it. Okay? Let us start it. Without wasting the time. So first of all, let us go through what? Next. So पिछली class में what we did in the previous class, visible on your screen. Plane mirror, spherical mirror, total reflection. So we'll start with a recall question now. As you can see on your screens, I hope it's visible to you. I hope students' screen is visible to all of you, na? Okay, for you people, I've started the recording also. Okay, recording is also started. Okay, this is the question on your screen. As you can see, this is the previous, okay, previous class question. Okay, so let us solve this question now. So here we go. See what is given there in this question. It says, I hope you have tried. The last question, it was on the PDF. See, किसी को अगर notes चाहिए हो, PDF is available on the link given to you, provided to you students. Okay. What it says like this: given that the velocity of the light in quartz is this much. Quartz कौन सा है इसमें? Quartz is what? It's basically this glass slab. So basically they have given you a glassy slab. This is a slab which is made up of quartz material. It's a naturally occurring element, no? So its width bhi de rakhi hai, T is equals to 18 centimeter. They have given this thing. Okay, they say that ki velocity jo light ki hai, it is 1.5 into 10 to the power 8 meter per second. So I will write this thing first. So this is how, students, you must approach the question. Write the parameters, the things which are given. So at least when you're going to, like, solve it, applying the concept, use your brain. At least you must have all the numbers, no? This will save your time. So velocity of light in quartz is 1.5 into 10 to the power 8 meter per second. Velocity of glycerine is 9 into 4 into 10 to the power glycerin, it says. So they have given the slab is present in this glycerin kind of material. Okay, slab is in the glycerin kind of material, and they say that what will the shift of the object produced by the slab? So basically, the object is here at 20 centimeter distance. Okay, so I have already given you a formula for the shift. Okay, let me write those things here. Suppose आपके पास एक slab हो like this. Suppose the slab is like this given to you in front of you. Okay. Suppose the slab in front of you is say like this. This is glassy slab. Okay. And the object is present in front of the glassy slab at 20 centimeters. This is object. Okay. Now, if you are observing the object from it, this is your eye, suppose. If you're observing the object from the other side of the slab, okay, which is having some thickness and say some refractive index, okay, and suppose this is the medium's refractive index in which the slab is present, this T thickness slab is present, okay. If you write the shift here, if you write the formula for the shift here, the formula for the shift is what? It is equals to, anybody? T, I have written this formula already in the theories, 1 minus mu of medium upon mu of medium, मतलब कौन सा medium? Surrounding medium. Mu of surrounding medium, okay, and the surrounding medium and mu of slab. Okay, you have to write these things. Thickness, you will take the slab thickness, and these are the refractive indexes respectively. And also I told you shift comes out to be positive. It means in the direction of rays, object rays. If the shift comes out to be negative, it is opposite to the direction of object rays. So if you apply this thing here, thickness is 18 centimeter. Okay. Thickness kitni hai isme? Thickness is 18 centimeter. Okay. And mu of medium is given? No, but the speeds are given 1.5 and 9.4. 9/4. Okay. So we'll compare like this. Mu of medium. We know this thing also. What's the thing? That if two mediums are there having mu1, mu2 are individual refractive indexes. Okay. If mu1, you can note down these things. Okay. I will give you the time. Just don't worry. I will give you the time. If mu1, mu2 are the two refractive indexes of the medium, and speed of the light is v1 here, and the speed of the light is v2 here. So we write the relation like this: mu1 upon mu2, v1 upon v2. Remember this. Okay. I've given you. I've also written like it's actually equals to lambda1 and lambda2. But we are only required of this now. Okay. So compare this thing with this: mu of medium upon mu of slab upon equals to me speed of the light in the medium, speed of the light in the slab. So you can use for this, you can use this equation, which I'll mark as like a second equation. Okay. And that equation is the first equation. Put the values here, you'll get the answer. You want me to solve? Yes. Okay. So this comes out to be thickness 1 minus, I'm putting those values, v1 upon v2. Fine. So this will give us slab. This is a general formula of the slab in terms of speed of light in the medium 1 having the refractive index mu1 and speed of the light in medium 2 having the refractive index mu2. Okay. So let us see the values. Values kya hai? See, you must also answer in the class. No, don't panic in the class. See, I'm not going to scold you for anything here. Online also, whether maybe offline. So thickness is 18 centimeter. And these are 1.5 and 9/4. So let us write the values. Thickness is 18 centimeter. These are quartz में कितना था? Quartz में 1.5. Okay, quartz में 1.5. So this is for not the quartz, but this is for the medium. So this will be 9/4. 10 is to power 8. And quartz में which is basically the slab, 10.28. Okay. Solve this thing. This is equals to 3/2. This will be equals to what? 2/3. 3/2. So net answer you will get shift का कितना आंसर आएगा? It will be equals to 1 minus कितना आएगा students? 3/2. This will be equals to minus 1/2. ठीक है? Which is minus 9 centimeters. If it is given, all the things are given in meter, you will write in meter. If all the things are given in centimeters, you will write in centimeters. So you can see here everything is in centimeters. Okay. Okay. But the velocity is in meter per second. But no issues. Since we are taking the ratios, no, ये तो ratio है, तो meter cut हो जाएगा. कोई मतलब नहीं उसका. Okay. Answer will come in centimeter. We got the answer is this. That is minus 9 centimeter. But if you focus there back, answer here is in magnitude, it is 9. But minus 9 gives you what sense? Anybody can answer me. What is the sense of minus 9? Minus 9 का मतलब है if object की rays अगर ऐसे हैं, so it is minus मतलब opposite to the object direction. So we'll find the virtual location of the object here. That is plus 9 here. ठीक है? I mean far away. So your eye will observe not towards it. That is not nearer. It will observe far away. And magnitude value is this plus 9. Okay, so C is the answer. Got it, students? C is the answer. Can anyone of you text me? Are you satisfied with the solution? If you want to write it, I'm giving you 15 seconds. Okay, so here is the solution. Now note it down. Note it down. Some students were having the doubt for noting down the solutions. Note it down. Okay, I'm counting 15 seconds. Okay. Okay, so let us move towards the next slide. Write this also. Okay, I will give you the PDF, है ना? ऐसे तो time लग जाएगा. I will give you the PDF. In that you can see properly. So this is our answer, by the way. This is our answer. Perfect. 9 centimeters in magnitude. Minus का मतलब far away. Positive होता तो मतलब if the object is here, this will be positive direction. This will be negative direction. It's far away direction. It's near direction as observed by our eyes. Okay. Okay, so now let us move towards our today's contents. So in today's class, we'll be studying a fresh new topic based on this major topic, from this major topic, by the way, which is refraction through the plane surfaces. Plane surfaces matlab plane spherical surfaces, by the way. Refraction through plane spherical surfaces, concave looking and convex looking. Okay, I repeat it. We'll study today. We have already completed recall part. So now we'll be studying today is a fresh topic from the major, that is the ray optics only. Because it's remaining. After this lens is there, okay, you can see it yourself. After this, we'll solve a numerical based on this refraction after studying the theory part. Then we'll go over the lenses, then we'll go for the lenses, and then we'll solve the class registration, which is based on lenses. So after this, only few topics are remaining, maybe 1 or 2, or maybe 3, if we extend it more. That is dispersion, prism, and power. Okay, so that I will, or some class restrictions like cutting of the lenses, maybe, okay, it depends. So in the next 2 classes, surely our ray optics will complete. And the next 2 classes, that is the next week, ray optics will complete. I will start from the next of the next week, or maybe in the next week Sunday, I will start wave optics. So next week we will try to complete ray optics 100%, and then wave optics will start as soon as possible. But main thing is this: it is about all about your satisfaction. So if you want more numericals, text me. Okay. Okay. So now let us start a new topic, that is, write the heading: refraction from spherical surface. Write the heading. No need to draw the diagram. Okay. It will be available on the PDF. The thing is this. What's the thing is? I'll be giving you the formulas and the applications. If these kind of theories cases are coming, and they are giving a spherical surface, and it's required from you to find the image distance. It looks like a concave and convex mirror, but actually it is not. It looks like it's a refracting thing. It's not a reflecting thing. Reflection nahi ho raha. So what I will do here is this. I'll give you a formula, and then we'll start. Okay. So see, if you are given a refracting surface like this, and suppose object is here, this is object. Okay, and image is here. This is object, this is image. Okay, if the rays are going from the object like this, okay, after getting reflected from this refracting surface, after getting refracted from this refracting surface, the rays goes like this and the image is formed here. See, this is the what? Pole, looking like pole, huh? But we'll treat it as like a reference here. Okay, so this point is a reference point of this center of this. We can consider this a spherical surface. And suppose the image forms at a distance which is equals to v. You can see it's shown here from this. Yeah, and the object is at distance u from this point center, pole looking like vertex kind of center point. Okay, so this reference point is m, and object distance is u, and image distance is v. So, and radius of curvature is given as r. Okay, so for this, the formula defined is what? This is on your screen. Remember this. And also, well, let me tell you here. So suppose this is a reflecting surface. Okay, this is the axis passing. If object is present here, u is the distance from this point, pole looking, vertex looking. Okay, it's not a reflection, it's reflection. Reflection will happen. Okay, an image forms here. This is v distance. And see, suppose this medium on the left hand side is something u1. So on this side, the medium is this having the refractive index. So two different mediums are there on in which this spherical surface, which will show the process of refraction, is present. And this is mu2. Okay, this is what? Mu2. So now you have to use this formula, and radius of curvature, suppose it's r given. So remember this formula, sign and conventions I will tell you, but first write this formula in your notebooks. Sign and conventions I will give you in the next slide. Okay, mu2 is the refractive index on other side. Mu1 is the refractive index on this side, object side, that is on the image side. R is the radius of curvature. Okay, this is the formula, note it down, and then I will tell you the sign and conventions now. Yes or no? Please respond in the class. Okay, let me see the YouTube boys, what they are doing. Okay, so I hope you have noted down. Please reply in the text box also. Text box also, it's important. Okay, you must reply in the text box. It's important. Chat box. Okay. Yes, students. JNV DU, JNV Ratnagiri, JNV Sangli, Satyendra Singmar. What about you, students? Okay. Dear students, please reply. Okay. You don't want to reply, sir, carry on the class. Okay. See, these are the important notes which you must write in your notebook. Okay. Just write it down. So you have to put above formula is valid for paraxial rays. Paraxial rays matlab rays which are near to the principal axis, making very small angle. Near to principal axis. UVR should be put along with the sign. Matlab U matlab object distance, V matlab image distance, R matlab radius of curvature. Mu2 is the medium in which the rays is going. Mu1 is the what? Medium for which the rays are coming. Okay. So we'll say here mu2, medium is the rays are going. इसका क्या मतलब है? मतलब image where the image is formed. You know, it's like this simple. Mu1, mu2. Okay. So now I will solve this question. First, this question will be a class illustration. Okay, focus here carefully how I'm solving it. Next, you will get all the idea. Don't worry, I'll be solving it very, very slowly. Okay, I will solve this illustration very, very slowly. Don't worry. I will write the formula again. I will tell you how to apply the formula. So focus here. You must have your 100% concentration here. Okay. If you have focused this question, 100%, you will be able to solve the other questions also. Don't worry कि सर मैंने theory नहीं देखा, मैंने formula नहीं लिखा, I haven't written the formula, I haven't seen the theory. No issues. If still you're not able to understand the theory related to this, please be focused when I am giving you the solution of this. I'll give very slowly solution, okay? So formula, how to apply, how to write the values, sign and conventions, all will be included as a complete jumbo package here in this question, okay? Right? So wait for it just for a few seconds. Okay, students. So this question is given you. Okay, 1.5 and 30. So I will draw this question for you. So here they are giving you a reflecting surface. Here they are giving you a refractive surface. Center point. Object is at 30 centimeters. Okay. And radius of curvature is 10 centimeters. And refractive index inside is 1.5. So this is say N2 or mu2. We can use any symbols. This is N2 or mu2. You can use any symbols. This is N1 or mu1 equals to air, that is 1. Okay. So now they're asking you what? If you see the question, they will ask you the image form. See, draw the appropriate ray diagram. See, it's not for you now. Okay, you can do it as a homework. Class illustration में इसका जरूरत नहीं है अभी. ठीक है? Got it? देखो इसमें तो they have already given you sign and conventions, but I will tell you how to take it. Okay. See, you can see here object is here at this point, and rays of the object will be of course like this, and this will be like this. I told you if you go in the direction of the rays direction, it will be positive. If we go against the direction of the rays direction, it will be negative. I repeat it. If we go in the direction of the rays direction, it is positive. If we go against the direction of the rays direction, it will be negative. ठीक है? Negative होगा. So yes. ठीक है, अब क्या करना है? अब just we have to apply the formula to find the image distance. Suppose the image is forming here. The image is at this side. Suppose. Let us assume whatever. Okay. I will write the formula like this: n2 minus n1 upon radius of curvature. अब radius of curvature, if you draw, see, since this is curved on this side, of course, the center will be located on this direction only. If this is curved, the curvature, the radius of curvature, the curved direction of this spherical surface is along this side. No. So we'll say center will also locate on this side. That means the radius of curvature will be taking like this in this direction, or it is in the direction of incident rays, that is positive. Okay. So n2 upon v minus n1 upon u. Okay, I will write it here now. Okay, I will write it here now. So now let us solve this thing. n2 minus n1 upon r, n2 by v minus n1 upon u. Okay. If you see here n2 is 1.5, n1 is 1. 1.5 minus 1 upon r, 1.5 upon v minus 1 upon u. Okay, this is 0.5 upon r. This is equals to what? 3 by 2v. minus 1 by u. This is equals to half basically. Okay. To solve it, this will be 1 by r, 3 by 2v minus 1 by u. If you focus on the values, u is, if you go from here towards the object distance, it is negative. It's negative because we are going against the rays direction. So you will take u minus 30. Okay, and radius is positive. So we'll take a radius as positive 10 centimeter. Also, see, let us check this out. Is this strategy right? Okay, so if I'm going to check it out, you can see यहाँ पे भी ऐसे दे रखा है. For you people, in like for convenience, u is minus 30 and r is plus 10. So put those values there. U as minus 30, R as plus 10. That is come solve करेंगे on the next slide. Okay, let us solve this here. If you solve this thing, which color? Blue. 1 upon, so it's like this here. 10, 3 upon 2v minus 1 upon minus plus 130. So this will give you 130 and this will be equals to minus plus 20. 3 by 2v. ठीक है, इसको solve करेंगे तो क्या आएगा? It became complex, I think. क्या आएगा? What will come? 6, 3 to the 6 plus 3 to the 6, 60, and this will be 2 by 3 upon 1 by v. This will give you is equals to say 90. Okay, so you will get here v is equals to, if you solve it, you will get v is equals to 90 centimeters, students. v यहाँ पे आएगा 90 centimeters. Okay, plus that is also plus, the answer is plus. So I will tell like this. See, it's very easy, you can solve it. Okay, मतलब object अगर यहाँ है, then the image is coming 90, मतलब positive direction है ये वाली, this is positive, you can see here also. ठीक है, so image will be at plus 90. So let us consider this. If this is 30, of course image will be here somewhere, okay, far away, है ना, क्योंकि वो तो 30 के बराबर ही है, it's like same as 30. So I will write here that image is at plus 90 centimeters. Image is at plus 90 centimeters. Audible? No. अगर थोड़ा भी audibility issue है, tell me in the class. Okay. So this is the image plus 90. कितना है image? Plus 90. Okay. So, and the image, if someone says you, what is the nature of the image? What you will say? Image is, since it's plus 90, it will be what kind of? It's real, 100%. No, it's real image. Okay. Now let us move towards this question. So I'll solve this question also for you, because this is just a beginning time for you people to solve these kind of questions. Anna, you want to try? Yes. Okay. So I'm giving you 30 seconds, 1 minute, most maximum 1 minute. Solve this question. For you people, let me write some sign-in conventions. So take like this key. How? So object distance, you will take it to be minus 5 centimeter by sign-in conventions. Radius of curvature, since it's curved in this direction, that is also in negative direction. So we'll take r here also. देखो, ऊपर वाले, in the previous question you took what? You took r as also positive. है ना? R is positive, but n2, which is this n1, which is 1, n1 is 1. Okay, let me rub this because it's maybe hiding this. This arrow is creating a problem. n2 upon n1, radius of curvature, n2 upon v minus n1 upon u. Okay, solve this question. n2 upon v minus n1 upon u, n2 minus n1 upon r. Solve this and get the answer. Solve it fast, students, you will get the answer. हो गया? You have solved it? No? Yes? No reply? Okay, मैं solve कर रहा हूँ. Okay, just focus. Apply तो करना formula. 1.5 minus 1 upon radius of curvature is minus 10. and n2 is what, 1.5 upon v minus 1, which is n1 upon u is how much, minus 5 centimeters. So ultimately you will get like this, equals to what, minus 1 by 20. This is what, plus 1 by, how much it is, students, 1 by 5. So if you solve it, you will get like this answer, that is, so this will be equals to minus 1 by 4. Okay, let me show you the next slide. So minus 1 by 20 minus 1 by 5 equals to 1 by v. So this will be equals to 20. Okay, this will give you minus 5 by 20, 1 by v, 5 1 5, 5 4 20. You will get v is equals to minus 4 centimeters. Oh no, v kitna tha? V was not like this actually. V is equals to 3 by 2v. Okay, so it is 3 by 2v. So minus 4 centimeter into, finally it will be how much? 4 into 3 by 2. So this will give you answer v is equals to minus 6 centimeters. Okay, so this is coming minus. Minus ka matlab, where it will be? Let me show you. Minus ka matlab it is here. So refraction is something different here, students. Okay, 6 pe aa raha hai. So it will give you kind of image real only, but on the other side. Okay, I hope you understood the question. How I solved this. So this will be equals to what? 0.5 upon 10. It's very easy, no? So minus 6 centimeters is the answer. Got it? Anybody is not replying. What's the issue? Please reply here if you understood it. Okay, let us proceed towards the next question now. Okay, now I'll give you the information about the, see, we have seen from the beginning that if plane mirror is present like this, object is moving, mirror is moving, image kya hota hai? We have seen the formulas. Kaise tha? Velocity of object plus velocity of image upon 2 is equals to velocity of mirror. With respect to ground, all these things. We have studied for mirrors also, whether it's reflecting mirrors, concave or convex. Usme bhi there was a formula. What was the formula? Velocity of image with respect to mirror is equals to minus v square u square velocity of object with respect to mirror. Was this the formula? है ना? Similarly, इसके लिए भी तो some formula must be there, no? For this also. There must be some formula for, I mean, when the surface is spherical and refraction is going on, so there must be some formula. So let us see that formula. Let's derive that. Okay, I'm going to derive that. Suppose you're having a reflective surface like this. An object is here. U image, suppose it is formed here. Suppose image is formed here. Okay, got it, students? मान लो ये refractive index is n2, this is n1 refractive index. Okay, and radius of curvature, suppose it is r given here, whatever. If I write the basic formula, we know this thing, it is n2 minus n1 upon r, n2 upon how much? V or u. If you see the formula, basic one. What was the formula, students? V hai na, it is V. Right here, n2 upon v minus n1 upon u, object distance. So suppose if this object is moving with some speed u with respect to ground, है ना? उसके लिए you have to differentiate as you were using the tricks for solving, for finding the such kind of relations in the plane mirror and spherical reflecting mirrors. Now we'll same find for this case, that is velocity of the image in spherical refracting mirror. Refraction, not reflection. Okay, got it, students? Let us check it out. Let us check this thing now. And differentiate karo isko simple. Differentiate this all thing with respect to time. इस पूरे को टाइम के रिस्पेक्ट में डिफरेंशिएट करो on both the sides. क्या आएगा? It will come like this. This is constant, this is constant, this is constant, 0. Cancel. इसमें this will come as minus 1 by v square minus 1 by u square equals 0. This will be minus v square. This will be plus n1 by u square. Okay? So this will give you like this. And yeah, one more thing will be there. Hold on. dv by dt will be there. This may be du by dt will be there. Okay? So let me erase these things. It's become messy here. So let's go towards the next slide. So it will be like this, n2 minus 1 by v square dv by dt with respect to this spherical. So this is all like if we are sitting here, okay, with respect to this spherical mirror, okay, and here it is equals to what? Plus n1 by u square du by dt with respect to mirror equals to 0. Okay, so this will give you the values equals to n2 by v square velocity of image with respect to mirror is equals to n1 by u square velocity of object with respect to mirror. This is the formula. Remember always. Okay. Now, these kind of things, like, you know, they have given the refractive surface, two different refractive indexes, and object is moving, okay, says with some speed equals to this much and this much, then how you find? So this is the way now. Apply this 5-star formula. This is made for you, okay? Now let us say this thing. Yeah, it is the same kind of question, which is based, this is application. The theory which you studied here, the formula which you derived here, this application is here now, okay? So now you people have demanded as per the feedback more numericals we want. That's why it's included, you know, it's like natural choice for the numericals. So students who studied like interested in physics, passionate about cracking the exams like IIT, KCT, NEET. Okay, maybe NDA you are preparing for. So you can see here, it's the same question. I will apply the formula. But first of all, let us see the image location. So formula simple, n2 I will be fast for this. Okay, I have to start the lens before ending the class, at least somewhat lens, one question at least. So n2 minus n1 upon r. Okay, n2 upon how much? N2 upon v image. Suppose the image is forming, let me use the black color. Image is here, suppose. This is the image distance. Okay, and then what? n2 upon v minus n1 upon n2 upon v upon n1 upon u. Okay, so 1.5 minus here is what? 1 radius of curvature curved on the positive direction, okay, plus 10. N2 again 1.5 v minus n1 1 u minus 30 negative direction, positive negative. Okay, very easy, very easy. So it is what? Minus का minus कितना होगा students? Minus 30. उसको solve करें, it will be 3 by 2v plus 1 by 30. This will be 1 by 20. This will give you this will be equals to so from here you will get v is equals to 90 centimeters students. Okay, v is equals to what? From here you will get v is equals to 90 centimeters. Okay, so I'll get a v value equals to 90 centimeters. But what we need, what is the question actually? Question says if the object was initially here and the image was at, of course we have solved this kind of question previously where we have founded v is equals to 90 centimeters. So if the image is lying here, if the object starts moving when it is at initial location of 30 centimeters from this point, with 2 meters per second like this, you can see. So what will be the image speed? This is the question. Simple. Kya karna hai? Let us apply this formula, 5-star formula made for you. So I'll apply this thing, n2 upon v square, n1 upon u square. Simple. Minus sign to hai nahi. So I'll be applying this n2 upon v square velocity of image. And with respect to studied this concept in kinematics, relative concept, relative velocity concept, that if someone says velocity of image with respect to mirror, it means this formula, n1 upon u square velocity of object with respect to meter. Okay, you can see in this question that they haven't shown mirror moving, so mirror is having velocity 0 with respect to ground. Okay, so I will put it there, 0 0 0 cancels, so we'll get like this. Okay, and the values are what? N2 is 1.5, V is 90. N2 is 1.5, V is 90 का square हो जाएगा, N1 is air, that is 1, U is 30 minus positive हो जाएगा, square हो जाएगा. Object की velocity is, this direction is positive, so and it is given here, object velocity is 2 meter per second. 2 meter per second, you will get the object velocity. ठीक है? And these are the things. So we have to find here V. One more thing, students, you must be worried कि यार ये सब तो centimeters में है, object velocity is given in meter per second, so we have to convert or what? No, because if you see the formula properly here, देखो इसमें centimeter का square आएगा, इसमें भी centimeter का square आएगा, they will get cancelled here. No. ठीक है, don't worry. Now let us apply these things. 1.5 into 90 into velocity of image. Minus 0 मतलब velocity of image. N11 U मतलब minus 30 का square मतलब 30 का square बराबर. Velocity of object is 2 meter per second. इसको solve करेंगे. 30 square 33 जा 33 जा. Okay, 33 जा 90. 33 जा 90. This is 3 by 2. 5 6 जा 15. 5 2 जा 10. 3 3 cancels. This is 1 by 6. Okay, so we'll get a equation here, velocity of image upon 1 by 6, velocity of image 1 by 6, 2. So from here we'll get velocity of image magnitude as how much? See this, 2 into 3, 6, 6 into 2, 12. So you cross multiply hoga, you'll get velocity of image is 12 meter per second. Got it? This is your answer. So students, got it? I will say here like this, key, if in this question, object was moving, this is object, was moving at 2 meter per second, image will be moving with 12 meter per second, but far, not towards the object, that is away from the object, because the magnitude is what? It's positive. And it's logical also. Because of diagram, if the image form, so if the object will also go near, no, I mean rays will also go in the same direction as the object is moving. If the rays are going in the same direction as the object is moving, they will meet somewhere far away at all the time in between the journey. I mean, when the object is like moving. So for all the time, rays will be meeting in what, in which direction, in which the object is moving. Again, it will like what? Progress here, progress here. So we will say image will be in the, which image will be moving in this direction. I mean, it's like constraint kind of thing. Okay, suppose you keep a block. Okay, so it's like very much like a constraint. Suppose if you keep a block mass m, if you connect a string like this and it's not slacking, it's taut condition. It is in a taut condition. So if you pull it here, so what's going to happen? This complete system will move in a constraint kind of thing, you know. So like it's like, you know, if a chain is there, so if you pull one, the last point will also move with the same displacement or same speed. It's all in constraint. Okay, got it? Now let us, transverse magnification is this simple formula. If somewhere they have given you the height of the images and height of the objects, then you have to use this formula. Got it? Transverse magnification, students, is just a very simple formula. Yeah, GNV DU and GNV Sanghi students, maybe some students have network issues. Okay. So what is transverse magnification? Very simple. Agar in this chapter, in this topic of refracting surfaces, if they give you height of the object also, and image height also, okay, these two things they have given you, and what do you need to do? And they ask you find the magnification, use this formula. It's simple, N1 into V by U with proper sign and conventions. Sign plus, if you're coming in the class without the revision, you will not get anything. At least see the PDF, see your NCRT. It's very important. You know, your students, your terms 2 are coming. Oh, sorry, terms 2 are over. You know, I mean, the exams are near the main exams. You're having few months to go in the college. So it's time to celebrate. I mean, you know, study well and think positive that we'll get a good college and we'll celebrate. And that process will give you motivation to go to move throughout this journey of like from the school to the college. Okay. So think positive, think like this, I'll get a good college, I'll get a good college, and study for that also. Just don't think, study for that. And it will happen automatically if you're really positive. Okay, so these questions we have already seen. Yeah, this question, students, this is the mixing of, this is the fusion question. These questions I call is like what? The fusion questions, fusion questions. How? Because two concepts are like mixed in this. You can call it like mixed, better for you. Because you can see here a refractive spherical surface. A spherical refractive surface is also there. And a plane mirror is also there. Okay. So these two concepts from the same topic, ray optics chapter, is mixed, and there you'll ask you the final image location. So these kind of thing, you know, you can try it yourself. I mean, use your brain, use the different formulas. देखो, इसके लिए तो you know the formula, but it will be, इसके लिए भी पता है, because object distance, if plane mirror is there, object distance perpendicular is equals to image distance perpendicular. Okay, object distance perpendicular is equals to image distance perpendicular. ठीक है? Finish. So you can study this yourself, and I mean, I'll explain you in the next class, but for now I have to start the lenses. So let us move towards the lenses. Okay, refraction through thin lenses. So lenses have started. Write this definition in your notebooks fast. See, I'll just solve maybe 1 or 2 questions if we have the time, then I'll end the class. Okay. Okay, write the theory a little bit. What happens, we have now different kind of reflective surfaces. We have studied till now different kind of refractive surface. I'm not telling reflection, I'm telling refraction. We have studied till now different kind of reflecting surfaces. Say what kind of, say concave looking, where we are having different reflective indices, and the formula was given by n2 minus n1 upon r and n2 upon v minus n1 upon u, or maybe convex looking, the same n1 n2. But what happens if we mix these two kind of surfaces together or join them? If we join these two brothers or sisters, what's going to happen? I mean, whatever you can call for understanding. If we join these two kind of structures and different manners, what's going to happen? Suppose I join them like this. Suppose I take this from here and I put it here, just nearby to it. So I'll get a structure like what? I'll get a structure like this. Okay. So this is a lens. Okay, suppose if I join them, if I join the same kind, if I copy it and join the same kind with this same, what's going to happen? Anyone? I can get a structure like this. What? See, this and this. This is also kind of a lens, like, you know, moon, first face of the moon. Okay. Or if you want to make copy that and just paste it here, it will get like this kind of thing. Got it? But suppose I take a plain reflective surface and paste it with this, I'll get like this kind of structure. This is also a lens. Or with this, I'll get this kind of structure. This is also a lens. So let me show you that what is basically the definition. So they define lens like this. A lens is a transparent medium bounded by two refractive surfaces. So these can be having this both, see, the refractive surfaces I've shown you can have radius of curvature or can have different, okay, when they are mixed together, joined together. So by joining this, we'll get a set of lenses, many number of lenses, okay. So what it says, a lens is a transparent medium bounded by two reflecting surfaces such that at least one of the reflecting surfaces is curved or spherical. So at least matlab, if it's plane, we take radius of curvature to be infinite. Plane refractive surface, we call it at a plano-convex, maybe plano-concave. Plano-concave kaisa hoga? How it can be? Anyone? So it will be looking like this. Okay, plano concave. If the radius of curvature is different, we say convexo lens or biconvex, because we know these are convex lenses. If they are same, we'll write as bi ki jagah. In place of bi, we'll substitute equiconvex lens. Plano convex lens mixed together, named as plano convex. This is concave convexity, and you can see this thing. So these are some important terms for you people. I'll not complete it, don't worry. The line joining the centers of curvature of the two bounding surfaces of principal axis. This is same as in the reflecting mirrors. Okay, so this line from the beginning we are treating as like what? Principal axis. But since this is a refractive surface 2, this is a refracting surface 1, these are mixed together, joined together like this. So iska center of curvature will be this, and iska center of curvature will be C1. Iska center of curvature will be this, iska center of curvature will be this. Okay, because center of curvature is the center point of which these spherical mirrors are the part, or surfaces are the part of. Of course, iska radius of curvature will be R2, iska radius of curvature will be R1. You have to observe carefully, okay? Now, this is the common formula for solving the numericals. Derivation not required because we are here for applications. NEET ke liye it's very beneficial. NEET syllabus, see it, okay? I mean, you know, go for the JEE, KCT. Start working now, okay? You are having a less time. So it's up to you in which college you want. So let me tell you, if you take a equiconvex lens or biconvex, let us take the biconvex. Suppose iska radius of curvature is in this direction, R2, iska it's in R1, whatever, okay? So I'll use this formula which is defined as 1 by V. I'll tell you how to apply S minus 1. इसका क्या मतलब? इसका मतलब है refractive index of the lens. Mu S का मतलब क्या? Refractive index of surface. Mu L का मतलब है refractive index of lens. Mu L means refractive index of lens. Mu S means refractive index of surface. Okay, 1 upon R1 minus 1 upon R2. Radius of curvature of the first side. Okay, see the formula, no? See the lens. This is the lens, and I'm writing the formula like this: 1 by V minus 1 by U, 1 upon R1 minus 1 upon R2, 1 minus refractive index of the lens inside and the surrounding medium. So this lens का जो internal refractive index होता है students, this is actually mu L, and this lens internal refractive index is mu L. External, in which the surrounding mediums in which this lens is kept is mu S. Okay, got it? Now I'll apply this formula to find, suppose the object is here from the optical center. देखो, lens में in the mirrors and spherical surfaces basically you can call same, but more precisely if I say in the spherical mirrors, concave or convex, you call the center point as what? Which kind of point? Polar vertex. But here you will call it as what kind of point? Polar vertex. क्या कहेंगे इसको? You'll call it as optical center. Remember, lens में हम optical center कहते हैं, and we use, you know, we have this kind of lenses we have used in geometry box, you know, to burn the papers side of the class, like somewhere from the window sunlight is coming. Okay, so focus will be treated at one. And we have written the formula to this big find from this complete is known as no. So in the next class we'll see students that these lenses do what? This equiconvex, suppose it is equiconvex having the same kind of radius of curvature, R1 equals to R2, or maybe suppose it is biconvex. So this will be behaving as like what? Converging lens. Okay, if you're having biconcave, this will be behaving like diverging lens. Okay, so you will say that by using different kind of lenses as per our requirement, if we want to converge the rays at a particular point, students, this equiconvex or converging lens or biconvex lens you can use for burning the papers. You know, let me remind you this thing. We were having that big geometry box in which, a lot of things comes, rubber comes, sharpener comes, scale comes, protector comes, what the things are that D comes, there is also kind of lens in that, like this small. So we use that, we were using that lens in this when we were small to do what? To burn the papers or to burn the dry leaves, and like when we were having like kind of break, like lunch break class only we used to do it. So this is the same. We use actually in that lens in the geometry box, the small it comes. Okay, it is basically inside the plastic case. It is equiconvex lens. So the sunlight comes like this. It converges all the light at the one point, and when all the sunlight is converged at one point, it creates the increment in temperature in a very small time, say dt. So it generates a heat kind of energy there. Okay, it generates what? It increases the temperature in a very small time. It's like impulse, in a small time, the force, the momentum changes fast by a very instantaneous force. Same here. So you'll get what? You will see that the smoke comes out from this leaf or paper. It starts burning. Maybe it may catch fire. Okay. So this is actually by this converging lens only. Got it? Fine. So students, bye bye everyone, and we'll meet in the next capacity. I mean, structure is very parallel kind of lines. Similarly, for converging, we showed this, diverging this. And you can see this point on the PDF. In the next class, I will start from this slide again. Maybe I'll start from the beginning of the lenses in the next class. Okay, this slide. Got it? So bye-bye, everyone. Take care. Be happy. Enjoy your rest of the day. See the PDF. Okay, watch the PDF. Don't forget to watch the PDF, see the PDF, and revise the concepts. And whenever in the next week we are having the class, I will complete this lens prism in the Sunday up to Sunday, next Sunday. All the things will be completed, and maybe next Sunday, last 15 minutes, or next Saturday, I mean next week, whenever we're having the classes, I will start a fresh topic, very fresh, like these flowers, which you can see is very freshy flowers. Okay, so I'll start with what story? A very blossoming kind of topic, that is wave optics. Okay, I'm ending the class. Participate in the feedback. I mean, if you want to text me something, you can text here. I'll end the class at perfectly 12. At perfectly 12, I'm going to end the class. Okay, bye bye everyone. Take care. Thank you for attending the class. JNV DIU students, JNV Sangli students, best of luck for your future. Be happy.